All right, so in this circuit we have a complicated series parallel network or circuit, and we're asking for the equivalent resistance of the circuit. So the first method I showed you to finding the equivalent resistance is to redraw this circuit in a more visually appealing way, and that's to start at the positive and start moving through the circuit. So there's the positive and the longer arrow. I'm going to move through here, and right here I'm hitting a split. I'm going to label that node A. All right, and so my redraw is going to start here with a positive. I'm going to move, and I'm going to hit a node. We'll label that A. A splits two ways. It splits this way and that way. All right, so let's deal with the short way. So here's our split, two ways. All right, and if it goes through here, it's going to go through a 10 and a 10 and get to another node. We'll call that B. So here I have a 10 and a 10. And now I'm at node B. Or the other way, I can come down, I go through a 16. Oh, and I hit another node. Let's call that C. So I hit C, and which way does it go? Well, it splits two ways. And it looks like I have an 8 and an 8. And then it comes back together. We'll call that D. So there's C, there's D, and then D matches up with B, and then we go right back to our source. All right, so now we're done. All right, so here you can really see that 10 and 10 are in series, so I can add them together. There's 20 ohms. All right, 16 is in series with this parallel combination. Well, 8 and 8 is the same as 4. And 16 plus 4 gives you 20. They're in series. And now notice from A to B, if I go the high road, I have 20. If I go the low road, I have 20. 20 in parallel with 20 gives me my answer of 10 ohms. All right, so I should get 10 ohms of resistance in this circuit. And so, again, this is kind of one way to look at it. You can clearly see what's in parallel, what's in series. Another way to look at this is this redraw method, and it's to isolate things that are only in series and only in parallel. So one thing I can do is I can take this circuit, and I can say that, hey, right here, 8 and 8 is the same as a 4 ohm because they're in parallel. And again, I can take 16 and 4. Well, that's the same as 20 ohms. 10 and 10 is 20 ohms. And then I can isolate and take 20 and 20, and I get 10 ohms if those are in parallel. All right, so again, if you were to plug those in those equations, that's what you should get. We get 10 ohms of resistance for this circuit.